All right, here we go. 10.4b. Sorry that that other video was so long. Hopefully this one won't be so bad. We have two more types of problems that you're going to experience in this section. So you had the two common tangent problems that we just did before. Now we're going to talk about two different types of walk-around problems. So a walk-around problem basically it does exactly what it sounds like. You're going to be walking around the circle or the segments going around in whatever direction you want. So what's happening in this particular problem is we have this circle and we have four tangent segments that all get connected. And so we end up getting this quadrilateral. And there's nothing special about this quadrilateral. Probably all four sides are different from each other. And they've given us three of the four sides of that quadrilateral. We have to find the fourth one. Okay, so first of all, if you look at these three measurements, what we're going to do is place them in the appropriate places. So we got 15 for BC, we've got 10 for AB, and we've got 18 for AD. And don't worry so much about how the sizes look different, like this shouldn't be 18, maybe 18 should have been up there. Doesn't matter. Okay, so first thing you're going to do, look at the segment that they're asking you to solve for. CD, it's right here. Okay, the segment that you're going to look for is tangent to the circle, right? And you have this point of tangency. Now you get to decide, where do you want to start? Do you want to start down here with this part of the segment D to this point of tangency? Or do you want to start up here with this part of the segment C to the point of tangency? And it really doesn't matter which way you decide to go, but one of those segments, either this one up here or that one down there, you're going to place an X. Okay, so I decided to start up here. Okay, so what you're going to do, and you're going to make sure that you're putting that X on one of the pieces of the side you're looking for. Don't put it over here, because you know BC and you know that AB is here, so don't put it over here, don't put it down here. You got to put it over there. Okay, now the walk-around problem depends on your two-tangent theorem. Do you guys remember what that is? It says that if you have two segments that are tangent to a circle, and they're starting from or originating from a point outside of the circle, then those two tangent segments are going to be congruent. So that means that if I've said that this segment right here measures X, then this segment over here also measures X. Okay? Fairly simple enough. All right. Now, moving on, they've told us that this entire segment BC has a length of 15 units. And if I know from here to C is X, I can say that from B to the point of tangency is 15 minus X. Okay? Now, once again, using our two-tangent theorem, if this tangent segment is 15 minus X, then that tangent segment also has to be 15 minus X. So at this point you can kind of get a feel for what we're doing. We're kind of going to be walking around all the way until we get back over here. And we're going to do that same process. Only now it's getting a little bit more complicated because we don't just have X. We have an expression, 15 minus X, for the length of this segment. Okay, so continuing on with our pattern, if the entire BA is 10 units, and I know that this part is 15 minus X, in order to figure out this part of the segment, I'm going to have to take 10 and subtract 15 minus X. And this is where people will tend to make their mistakes. Please, when you set this up, use your parentheses. Okay, so I'm going to take 10 and I'm subtracting this entire expression. Because when you subtract the entire expression, you have to distribute your negative sign to the 15 and to the negative X. So you'd have 10 minus 15, which is your negative 5, which is right here. But a negative of a negative X turns that into a positive X. So if you don't do this right, this expression is going to end up being wrong, and then the rest of your problem will be incorrect. So now we know that this length right here, from A to the point of tangency, is X minus 5. which means that this segment, using the two-tangent theorem, is also x minus 5. Okay. Now we're going to do the same thing again. It's very repetitive. This whole thing here is 18, and we subtract x minus 5 to get this segment right here. So we'll take 18 minus parentheses x minus 5, distribute your negative, right? So this is going to be a negative x, but when you do this, a negative of a negative, we actually are adding 18 plus 5 to get the 23. So now we know that this length right here is 23 minus x, which means this segment right here is also 23 minus x. Now this is the weird part that people have an issue with sometimes. We are looking for the length of CD, and we have CD broken up into two segments. This one up here, and this one down there. If we add these two together, we should get the length of CD. So look at this. CD is going to equal 23 minus x plus x. And what happens is that these two x's cancel each other out, and you're left with CD is equal to 23. Isn't that brilliant? I love it. Okay. So that's the first type of walk-around problem. Just remember, always start with one part of the side you're looking for. This isn't going to work very well if you start over there. Trust me, I've seen it happen before. Okay, next problem. This is another type of walk-around problem. What we have are three circles that are all tangent to each other. And what they've done is they've connected the centers. So we have three lines of centers here. Okay? And they've told us the length of AB, BC, and AC. So basically they've given us the three sides of this triangle. So let's put those in. We've got 10, 8, and 5. They're asking us to find the radius of circle A. So what we're looking for is from A to this point of tangency right here, this radius. So I'm going to go ahead and label that x. Well, from A to that point of tangency is also the radius of A, so it also has a length of x. So this is going to have the same feel as the walk-around problem, but we're not using the two-tangent theorem. We're actually just using the idea that the radii of a circle are congruent to each other. Okay, so walking around, you can decide which way you want to go first. If we know that this whole length right here is 10, and this radius is x, this piece right here, the radius of circle B, has to be 10 minus x, which means this also has to be 10 minus x. Okay. Now, if you wanted to, we could continue on getting this radius as being 5 minus 10 minus x, and do the parentheses and subtract and all of that. And you can continue on and go all the way around until you get here. You can add these together, but this time you'd have to equal it to 8 and then solve for x. But I personally, when I do these problems, I like to do it a little differently. And it's totally up to you how you want to work it out. I go one way, and then I stop once I get here. And then I go back to circle A, and I go the other direction. So if this is x, and this whole thing is 8, I can call this 8 minus x. And then that means that this radius also is 8 minus x. And I like to do that because then there's no confusion with parentheses and distributing negative signs and forgetting and doing the subtraction wrong and all that. All those careless mistakes that I see students make. Because this way, now I have 10 minus x for the radius of B and 8 minus x for the radius of C. And I know that these two radii added together are going to equal 5. And so I can just come up with that equation. 10 minus x plus 8 minus x is equal to 5. And now I just solve for x. So if I combine like terms, subtract the 18 and the 5 and move the 2x to the other side, and divide by 2, I get x is 13/2. And then I'm done. Now had you gone around and called this 5 minus 10 minus x, and then 5 minus 10 minus x, and added these together, set it equal to 8, if you want to try it, go ahead. You should get the exact same thing for x. And if you don't, that means you did some kind of subtraction or addition wrong. Okay, those are the two types of problems that we're going to be worried about in 10.4b. So luckily this was a lot faster than the first one. By half. Wow. Okay, we're done.